Я скажу пару слов о сегодняшнем нашем мероприятии, наверное, по-русски, потому что дальше разговор уже пойдет по-английски. Значит, сегодня у нас в РК в гостях Марк Бунгер. Он главный исследователь в компании Lux Research. Lux Research — это наш партнер. Компания является всемирно признанным лидером в области исследований в различных технологических областях и в области инноваций, и делает большую работу для, в общем, своих клиентов во многих-многих странах мира, в том числе и в России. Я думаю, что, наверное, Марк лучше меня расскажет еще чуть-чуть о своей компании, и чтобы не тратить время, и ваше, и его, я передаю микрофон Марку Бунгеру. Welcome, Mark.
Thank you, спасибо. Hi, everyone. Добрый день. Меня зовут Mark. I think that's about all the Russian I have right now. My name, again, is Mark Bunger, and my company is Lux Research. I recognize a few of you, at least, from when I've been here in the past, and this is about the third time I've been in Russia in about the last 6 months. So I always enjoy coming here, and it's a big honor to speak with all of you. So we're not having simultaneous translation. I will try and speak very slowly. I believe we'll have translation for the questions. Maybe you heard all this. But you can have the slides as well, so you'll have the material in writing, and there are also hyperlinks so that you can follow and click on to certain things where there's even more information. Okay, so very briefly about Lux Research. Now you can hear me. What we do is look at technological innovation in a number of different fields. These are our teams, how we're organized in these topics. So things like advanced materials, autonomous systems, robotics, energy storage, solar, energy electronics, and so on. Each of these areas, we have a team that's looking at venture investments in small companies, in startups out of universities, as well as the big picture where industrial activities, regulations, market trends are going on. And we bring that information together in written research that we publish, also in workshops and reports and other things that we do specifically for clients. We have about 90 people around the world, and we're about 10 years old. We were spun out of a venture investment company called Lux Capital in 2004. So we have a lot of interesting technologies to talk about today, so I won't spend any more time on this, but please let me know if you have any questions about Lux Research. Today, the topic is growth in innovation, looking at markets, technologies, and new strategies. So the areas that I'll go through are looking at what are some of the technologies that we're watching today, what are some of the opportunities and needs in developing markets, especially due to big changes like climate change, the mental and cultural mindset for growth. Just yesterday, I was at the Moscow State University for Mechanical Engineering. So you have a lot of students, and a lot of what they wanted to hear about is just sort of the basic mindset, you know, asking questions and not sitting silently if the person speaking asks you something, or networking, or things like that, that are a cultural shift that's already going on in Russia, and it's prevalent around the world. And then finally, some specific things that, based on my interactions with Russia and my team's observations also with Russian entrepreneurs and investors outside of Russia, and what we've seen working with RVC and other companies within Russia, some specific ideas for how you can get started. So looking first at the technologies, there are broadly three areas that I'll talk about today of all these different areas that we cover. Some of these are also covered in that, but some are also new. So first, looking at wearable electronics and ambient electronics. Ambient means that it's really in the atmosphere, it's just sort of everywhere. Robotic and autonomous systems, and then distributed manufacturing, which is a new way of doing manufacturing, a little bit like just-in-time manufacturing or lean manufacturing was new in the 80s. So one of the things that we look at, as I said, are new technologies. And one of the wearable areas that got started about 2 years ago was smart watches. So this is the Pebble smartwatch. As I said, this is about 2 years ago. Apple was talking about that they have a lot of patents. They have a large team working on wearables. They still don't have a watch or anything like it. Samsung came out with a watch just in the fall, around September. It wasn't very well received compared to the earlier things like this watch, the Pebble. It was under-featured and over-expensive, and it didn't last very long. You had to charge it a lot. So even these big companies are having trouble competing with small startups in the area of wearable computers. So this, as I said, this is a smartwatch. I happen to be wearing one. So I'll pass it around so you can look at it if you like. Basically, this is like a small screen for your phone. So if I get a text message, it shows up on this. If I want to take a picture of you, I can put my camera over there and press the button here, and it will take a picture. So a lot of the features and information I get on my phone, I can have on here. So, but the phone, or sorry, the watch itself, while I think it's kind of interesting, the real interesting part and the most important part, I think, is the story. So you can press buttons, you can't break it, so don't worry about it. So the story is this. This is a 27-year-old Canadian engineer named Eric Mikovsky. He had the idea for this smartwatch, and nobody would give him any money. He barely got any attention at all from venture capitalists because it's hardware, and nobody was investing in hardware in 2012. So he went to an accelerator called Y Combinator, and there he got a little bit of money. He also got some support in developing it. And he, as part of that work, put the watch on Kickstarter. So how many of you have heard of Kickstarter? Almost all of you. Great. So he put it on Kickstarter and wanted to raise about $100,000 to make 5,000 watches. So he had a kind of a modest goal, but $100,000 is a lot of money for a 27-year-old with his first product. He ended up getting 85,000 customers and over, I think, $10 million. So that's great, except now he had to make 85,000 watches in the same time frame that he had planned on making 5,000 watches. So he actually had a huge problem. The rescuer was this company called Dragon Innovation. So Dragon Innovation is supply chain experts and robotics and electronics experts from that used to work at iRobot and wanted to start a new company. So what they do is basically they're sort of like the caterers for a wedding. If you have one big thing that you don't know how to manage and run, they'll come in and be the experts to help you establish, in this case, a company and a supply chain, get your product made, get it shipped, get it quality controlled, and everything else that you as a young inventor and entrepreneur have no idea how to do, and then they go away. So they're we call these pop-up supply chains because they sort of pop up and then they go away. So this was a really milestone effort in this new kind of manufacturing I'm talking about. So while it's a very important device, and I think it did well as a product, the real lesson is in the manufacturing process. So where is Pebble today? This is the latest development kit that they've created. So when they had such success on Kickstarter, it wasn't that they sold a lot of products that really made this a good company. It was that they got thousands of developers thinking about how to design applications for their platform. So the same way that iTunes and Android and all the typical applications that we think of really depend on a developer ecosystem or a music provider ecosystem. The same thing is true for these wearable devices. Just being able to measure one thing, like your fitness, is generally not enough to make a device successful. In this case, they have now just launched a developer kit for smart homes. So all kinds of devices that we would think of as part of a smart home offering from one company. More and more, this is an open offering where anybody that knows the protocols and has the best interface and has the best tools can compete. So Pebble is going into more and more new areas. The one before this was in fitness. So all the fitness trackers that measure how many steps you took in a day, like Fitbit and Misfit wearables. The Pebble has an accelerometer, so it can do those things too. So it can do all kinds of things that all these single-purpose devices did in the past. So this, again, is part of the real benefit is not just the product, but the process and how they got there. Now, you know there are lots and lots of devices out there for wearables, and they're getting better all the time. So this is the Samsung Gear, the product I mentioned that came out from Samsung that wasn't very well received. This is a Fitbit. It has a watch and some other functions, but again, it really only does one thing. This is a Ring. It's also on Kickstarter, and with this Ring, it has also accelerometers, and if you want to send somebody a text message, you write it in the air with your hand, and then you hit send like this, and it senses from the movement of your hand what you've done, and sends a text message or starts your music or whatever. This is a product that you can't buy yet. It's Android Wear, and so this is basically Google's approach to the smartwatch. And they're really, really beautiful watches, unlike the plastic one that you are looking at right now. It's metal. It really feels like a good solid watch. It's a beautiful object. We'll have to see if it performs when it actually gets launched. Anyway, the point of all these is that a lot of these are getting smaller and lighter by collaborating with other devices like your phone for bigger pictures, which then collaborates with other things around you. So rather than trying to fit all the functionality onto one device that's going to be very heavy and hard to use, the assumption now is that everybody is going to have a cloud of devices on their body and in the room. And so if you need a big screen, you won't necessarily tether that to one person's PC. I might be able to show my own data on this screen. So that's what we see emerging right now in California. Another thing that we see, and I think this is very important for the future of wearable devices, is what are called instant wearables. This isn't the name of a company. It's a way of making wearable devices. So I also have an example of this. This is my bag of toys. Instant wearables are basically small electronic modules that are very simple to use and to integrate, so that even though they say anybody can make a wearable device in 30 minutes, maybe not anybody, maybe not my mom or my kids, but certainly anybody with a slight mechanical or electronic inclination and the ability to do a little programming can pretty much put together a wearable device with any of the features that we've talked about in a few hours and for very low cost. So each of these modules, this one, which has pretty much all these sensors that you see up here all in one chip, is about $80. And these modules from a company called Seed Shadow is the name of the product, are anywhere from $5 to about $45 a piece. And you just connect them with a connector, and they figure out what is on the chain. There's an accelerometer, there's a GPS, there's a compass, and then based on what you've programmed them to do, you have a wearable device. Now, you obviously can't wear a set of circuit boards, so they have 3D models that are available to be 3D printed for anybody who has a 3D printer and adjusted. Those are free and available on their sites or on GitHub. So like I said, I'm going to pass these around. Now these are in the packaging. You can take them out, be a little gentle. This is, so what I've been trying to do is put together something that would go in a glove. So if you're doing martial arts, for example, or exercise, and you want to see how much motion your hand has had in different dimensions. This contains, there's a battery, the main circuit board, an accelerometer, and then a little screen. And I'm going to hook these together so you can see the little screen. It's an AMOLED screen, LED screen, and it will say Hello World, because that's my way of knowing that it's actually on and connected. If it was connected to a computer, we could also see the acceleration in 3 dimensions. And this took me roughly an hour from opening it from the box to finding out what I needed to do to putting it together. And I'm not an engineer. Here's also some other screens and memory modules that you can look at. Okay, so usually if you demo hardware or software, it's not going to work. Yeah, it's a good way to invite bad luck on yourself, but I'm comfortable that these will work. So anyway, the point is, with a really minor investment, not only do you get from idea to prototype, you can sell this. It's prototype to product also. And this is really, really important. Again, this is one of the key reasons this is such an important new way of thinking about product development, is because in the past, you would have a circuit board like that. It was very fragile. You couldn't really think of packaging it up and selling it. And so the next step after you developed it would be to test it and then think about packaging. These things eliminate that step. So if you figure you have a market for 100 of something or 10 of something and you can do it profitably, it's okay to go after that. And then if you find out that you're wrong, the market was only 9, you're only out a few $100s. If you find out the market was 9 million, you've already started manufacturing and selling. So it makes it even easier to start a hardware business. Kind of the way it's very easy to start a blog or a software business. You can really prototype in hardware now as easily as you can do in software. Another area that we're seeing a lot of investment is in drones and small satellites. So drones is a sort of a loose term that means a lot of these autonomous aerial vehicles. Some are balloons, some are quadcopters like this one, some are octocopters, some are tiny, some are very big. But all in all, there's a lot of investment going into these. So we've seen Titan Aerospace was bought by Google for $60 million. Facebook bought Ascenta for $20 million. ConocoPhillips, Monsanto, BP, a bunch of other companies in oil and gas and in agriculture are looking at drones as a way to replace other equipment like trucks and things like that, where a human would go out and inspect something. Now they have a robotic way to go out and do that. Similarly, on small satellites, this is something called a CubeSat. It's just a standard for small satellites. It's not one particular satellite, so it basically is a standard that if you can fit your device in a 10 by 10 by 10 centimeter cube and a few other things, you can actually launch that. So there are hundreds of CubeSat projects in the works. There are high school teams that have CubeSat projects going on and going up to the International Space Station. It, again, is a very, very easy technology to get into space. So CubeSats and some similar formats of small satellites are also getting a lot of investment. Planet Labs just raised $65 million. Cometa raised $62 million. And Skybox was just bought by Google for $500 million. So you might wonder, why are they spending so much money on these things that are kind of, like advanced toys? There's certainly an opportunity to provide new services like imaging or connectivity in difficult to reach places, but there's a really important strategic reason why these companies are spending so much money. So, and it's built. So, and that's network connectivity. So Google, Facebook, Amazon have all been looking at using drones to deliver network connectivity to areas where there's poor service today. But that sounds like a nice gesture. But what's really important is that in the United States, the broadband, the landline providers, AT&T, Comcast, Verizon, have been fighting to reverse something called net neutrality, which basically means that they have to treat all traffic equally. So what they want to do is charge YouTube users, Facebook users, etc., more to access those sites. And they want to get paid for that. So Google needs a strategic way to tell AT&T and those other companies that if you do that, we'll just go with our own network and we'll go straight to the users. So it's a very strategic way for them to essentially say to the companies, again, Comcast, AT&T, Verizon, that strategically we don't need you anymore, and if you treat us poorly, we'll make all of your infrastructure obsolete. Nobody will need to use an AT&T subscription to call on the phone. You can just use your Google phone straight to the drone in the sky. And if we have more users, we need more bandwidth, we'll just fly some more drones. So it's a very scalable way to address this problem. Very strategic. Another area where we see this type of new technology making new strategies happen is in autonomous vehicles. So I'm sure you've all seen lots and lots of news stories by this time about autonomous vehicles. Google, just to recap, a few years ago, Google surprised everybody by saying that they had actually been driving their autonomous vehicles not in the desert or on a special track, but between their offices in the Bay Area in California. So they're already on the road, already navigating real traffic. And they also said, this was in 2013, they said that in the next 5 years, so by 2018, they wanted to make this technology available. So lots of other people, this is a Volkswagen car, a GM car, a Nissan car, lots of other companies, car companies have been working on autonomous vehicles for a long time. And you might think that they would think, oh good, we finally don't have to work on that anymore, there'll be a solution. But that wasn't how they felt. So this is, this quote in red is the important one. This is the CEO of Nissan. I was at a meeting with him and a lot of other people right about the time this announcement came out, and he said this: "We've seen what Google did to the phone manufacturers, and we don't want that to happen to us." So specifically what he meant here is that Nokia was the unquestioned rival, or unquestioned dominant player in mobile phones until Google launched Android and the iPhone came along with iOS. And from there, as you know, just this last year, they actually have plummeted all the way down to bankruptcy and had their handset business bought by Microsoft. So in the automotive category, what this would mean is that Google says, okay, we're going to make this operating system available not just to BMW and to General Motors, but also to Tata, the Indian car maker, to Chery and Geely, the Chinese car makers, and they can now compete on the same level as Nissan and these guys. That sounds kind of crazy, but if you think back, how many of you had a mobile phone in 2008? Yeah, you all had a mobile phone in 2008. The phones that were available at the time from Samsung and HTC were really not very good phones. They were kind of a third-tier player. Today, Samsung is definitely the dominant player. HTC is also very, very strong. They're certainly stronger than Nokia, and that's because Android gave them that ability. So Android basically lifted these two bottom-tier players up to the top, and the same thing could happen in automotive. That's what the car makers are really afraid of. So again, these technologies are not just, oh, that sounds like fun, I might pay more for that. In their case, they have to have it or they could be dead. So looking at autonomous vehicles, I don't expect you to read the text up here, but basically what it says is that there's a pathway from 0 to 4, which are different levels of autonomy. 0 is a car that you have to do everything. A typical car from a few years ago. Most of us already drive level 1 cars that will do things like help with braking or warn if you're getting out of a lane or things like that. Level 4 is the fully autonomous journey. You get in the car, you tell it where you want to go, and then you crack open a beer or whatever you want to do while the car drives you home. So in each of these steps, there are a number of different technologies that have that compose a different value in the car. So as today, we don't need very advanced radar and LiDAR systems for the levels of autonomy that we have. But as more and more of those more advanced autonomous systems come out, they'll need sensors, they'll need software, they'll need other technologies that are in development right now in order to provide that degree of autonomy. So we looked at this. Again, I don't expect you to read the entire chart, but basically this is a breakdown of with the different components like radar, LiDAR, optical cameras, wiring, computer hardware, and so on. What components will be purchased in each level of autonomy times the number of cars in that level that will be sold from here to about 2030. Now 2030 sounds like a really long time. We normally wouldn't try and make a forecast out to 2030. The car industry, though, is very predictable because it's a very established industry, and two, we have a lot of history of how long it takes for different technologies to be adopted. So while this is still an estimate, and we have high cases and low cases and lots of other angles on this, this data, this is our sort of middle case scenario, and it's based on a lot of data about how previous technologies like anti-lock braking and airbags and so on have been adopted. Any questions or comments so far? Can you understand my speaking okay? Good. That's good. So, oh, yes?
Actually, we have a question from online audience.
Okay.
So, Olga Sternik asking you, "Hi Mark, I wonder if controlling smartphone system remotely from Pebble is secure. Could it be easily hacked?"
So the question is, can the Pebble smartphone connection be hacked? So it uses Bluetooth, and it's as secure as probably any other, secure or insecure as any other Bluetooth connection. So just like any other Bluetooth device you have. Okay, so another area that's related to cars and drones is other types of robots. Autonomous vehicles and autonomous flying vehicles are really just autonomous systems, which we also call robots. And I chose two of the ugliest robots I could find because as much as we think of robots, they're coming, they're great, it's still really in a rudimentary state of development. And many of them are really more either prototypes or toys. But the reason that we see these also starting to get better and smarter at a very fast rate compared to what they've done in the past is because of what I mentioned earlier, that you have so many different sensors and so many different devices that they can call on now that weren't available in the past. So the robot had to be really a completely fully contained autonomous system able to navigate any environment that you presented it with without any preview. But now, since so many of our buildings are mapped out in advance, our streets and highways have also been mapped out in great detail, the sensors are getting better, but it's really because they're not stepping into a new environment every second. They get a preview of the environment that they're moving into. So they can use all this other information to not only know what to expect, but also to plan and test out different strategies or actions. So it's not real-time robotics or real-time processing. We're starting to think of new words for this, but something like pre-real-time. RTOS is a real-time operating system. So pre-RTOS is a new concept we're sort of playing with, where you have systems that anticipate what are the likely things that will be facing me in a few seconds, or a few milliseconds even, and what might I do about that? So another example of that is kind of alluded to here with the goggles. How many of you have heard of Oculus Rift? It's a virtual reality system. Okay, so Oculus Rift is it's a virtual reality headset. You put it on and it's like a ski goggle mask, except it's got a screen inside it. Like you've all heard and seen about virtual reality, when you move your head around, it gives you a three-dimensional picture of where you are. Now, as you know, people have been trying to do that for decades at this point. Why Oculus Rift has been so important and why Facebook bought it for billions of dollars is because this is a technology that really, really has worked out. And the way they did that, they had a number of different innovations, but one of them was this ability to predict in advance where your head would be. So when you move your head like that, there's some acceleration, and it can measure how fast you're moving, how quickly you might slow down, and when you start to slow down. So it can pre-paint the pictures that will be over here that you're going to need to see before your eyes actually get there. And that was really critical to making you not have this lag where the picture doesn't keep up with your head, which makes you feel sick and also doesn't give you a very immersive experience. So this is what I mean about being able to see in advance. Robots and all these other systems we're developing have more and more capability to anticipate what we might do. Now, there are a lot of implications of that that are also possibly bad. Those are things that we should think about and do think about. But right now, I'll just talk about how they apply to these devices. Another way, like I said, that these sensors are coming all around is in a field of optical sensor called depth cameras. So if you have a Kinect or an Xbox 360 game console with a Kinect at home, you already have a depth camera. What depth cameras do is they can basically see in 3 dimensions without having to have sensors, say, all around a room. And they do that, not to get into the technology too much, but they do that extremely well. the Xbox 360 camera, which is, you can buy them for $40 used. They're, very, very cheap. They can recognize gestures. So if you go like this, that could be turn on the lights or start the stereo or doing things like that. They can recognize how your body moves and all your joints and everything. So that gets translated into instructions. They can also recognize gestures. So if you're smiling, you're blinking, things like that, all those things, again, it can interpret. And there are lots and lots of developers turning that information into things like reading emotions or predicting, again, what you're going to do next. So, for example, one of the applications you can get as a game is a coach for training. It watches you play a game, and it can basically say how you're moving and how you could be moving better. So this technology obviously has a lot of use. If you start thinking about, maybe every room starts to have a depth sensor just to be used for security, but also to maybe be the smart interface with the system where you turn on lights and things like that by gesture. So another example of big investment here, PrimeSense is an Israeli company that was making depth cameras. Apple bought them for $345 million. I think they might have bought too early and too expensively because there are zillions of depth camera developers out there. The technology is really not that hard. So a little bit like smartwatches. The first one's really neat, but don't overpay for it. There are lots and lots of depth cameras out there, and if you're developing a system that will use this or compete with this, you should know kind of the state of the technology. The cheap Microsoft depth camera can actually measure your pulse by the changes of the color in your face, which we can't see, but it can see. So they're really, really amazing cameras. There are a lot of other things that are out there. Contact lenses. We're seeing a number of companies developing contact lenses and hoping to commercialize them. This is an electronic contact lens, so you could have some information displayed in front of you. But that, I think, within the next 5 years, we'll certainly see a first commercial wearable contact lens. Other things for smart devices that attach to your socks and your underwear, and these are some transdermal patches. So these actually deliver drugs that again are modulated by, say, your cell phone or some other external device. And we see this ultimately coming into an ecosystem we call the Internet of Living Things. So you've heard of the Internet of Things? Yeah, so the Internet of Living Things is something that basically includes us. So the same way that the Internet of Things measures things like temperature or performance attributes of a device, say its electrical draw or its level of battery level, things like that. All these biosensors connected to the system start to become an internet that includes our physical, that is our biological parts. So two interesting companies in this space. One is called NeuroSky, and it's one of several developers in this field. But it basically is a headset that can read your brainwaves and allow you to control things like toys and games. They also have more industrial and medical applications. But the point is, it's literally a mind-reading machine. This is another one where I do a lot of this with my kids, as you'll see in a minute. We bought one of these, took it apart, connected it to an Arduino, that to the computer, and then you can basically control stuff on the computer just wearing this headset. Backyard Brains is another company in this space of neural integration. So they make a little a circuit board that you can see here. It's on the back of a cockroach. It's a big cockroach, and I'm sorry I made you see a cockroach. But you attach it to the cockroach's antennae, things on its head, and then you can control it with your smartphone. You can make it go left and right and things like that. So this is how they sense when they're bumping into an object. So you can essentially pretend, tell it that it's bumping into an object even when it's not. I see some of you going like this and some of you going, that's a really good idea. Anyway, so the point is, these are new technologies. They're kind of toys and prototypes at this point, literally, but give them 3 or 4 or 5 years and you'll see these in more and more types of applications. Another type of interface that we haven't really thought of. So printed electronics are basically electronics printed on a flexible substrate. So this is a screen, as you can see. It's on a flexible plastic. All the parts are printed on here and the LEDs. And when you have this, you can create new types of gestures. Like we all know now that this on a touch screen means shrink. This means make it bigger. So you can do things like twist and bend and roll that will also become part of the way we interact with machines. Voice interfaces, we all know what those are like. I actually met a Russian company earlier this week called Cubic Robotics, and I'll show you a picture of them in a second. But they're making what they call a Siri for your house. So it's a cube that you talk to, and it talks back to you. It can control the things in your house. They're also talking about making it in your car. And they're actually not very far from here at a hack space that, again, I'll tell you about. So voice interfaces, that's another way we know that we'll be working with computers. Another one, I mentioned already, neural interfaces. So here's somebody trying to make a 3D model using just her brainwaves. She's thinking very hard about it. Anyway. So when we bring all this together, we've got a lot of different interfaces. We're all used to designing interfaces. Maybe some of us have designed interfaces for things like websites or applications. We know wireframes, we know buttons, we know a little bit of the touch gestures. But when we have all these other ways, all these other interfaces, hardware and virtual with our machines, and those machines are getting smarter, we're getting into this area where we have what we're calling AI UX, the artificial intelligence user experience. And what is that like? Well, nobody really knows. We all know now intuitively how to use a drop-down menu or how to use a mouse. But when I first started with computers, we had to make people play solitaire so they would have the hand-eye coordination to use a mouse because they were all used to text screens. So now, what are those things that we'll have to learn? Who's going to develop them? What companies and what institutions will develop these ideas the way Xerox PARC developed the graphical user interface? Well, we started bringing some of these companies together. So here we've had 2 workshops at this point where we bring together, for example, IBM Watson, Amazon's Secret, but it's not Secret, Lab 126, Stanford University, Hyundai, Intel. So a bunch of these companies that all have some aspect of the answer to this problem. And we do workshops, they come up with ideas, and over the course of the year, we hope to have a number of these and then document our findings. So if you're interested, just let me know or keep in touch, and we'll see where this goes. We could have one in Russia, too. So moving into things that we don't really think of as IT. As I said, advanced manufacturing, I think, is the real important outcome of all these things that are happening in IT. IT happens very quickly. It evolves very, very rapidly. Compared to any other industry. So it's very good as kind of like a fruit fly is useful in doing genetics research because they live and die very quickly. You can see changes quickly. IT is a good monitor for how other things, other species of industry will evolve. So this is a company called Life Shoes. They make these shoes that are basically all the components are renewable or recyclable, and their idea was that they will make the shoe, and then when it's done, you send it back and they'll demanufacture it and make parts of it into new shoes. They also came up with this idea. They said, hey, we could put an Arduino microcontroller in the heel. Does everybody know what an Arduino is? How many of you? Okay, not so many. So the little thing that I was sending around, the controller on that is Arduino. So Arduino is kind of like HTML in the sense that it's a standard that anybody can build something to. It's open source, and there are dozens of Arduino standard microcontrollers out there. And if you write a program for one, you can generally move it to another. You might have a bigger, more stronger one, or a smaller one for a wearable, but it's a platform. And they said, we could put an Arduino in there. We don't know what you would do with it, but we'll give you the space and you'll figure it out. So we have electronic shoes all of a sudden. And again, they didn't really think about this. This is just, it's so easy and so inexpensive to make things connected. Let's just do it and see what happens. So this is a really great, product, and it was a Kickstarter based product as well. But something really interesting happened in the process of doing the Kickstarter. So the reason they needed to raise money was because if you're making shoes, you have to have a mold for each size shoe, left and right. Okay, so you're going to build a mold. The molds are pretty expensive. They're $10,000 or $15,000 each. So if you wanted to have, say, a full range of sizes, men's, women's, half sizes, everything else, you'd have a lot of investment up front to be able to make a few shoes, and they didn't have that. So they were going to initially launch with men's whole sizes between say like the equivalent of say 38 and 45. So, you're still getting a lot of customers in there, but you're still missing a few. Throughout the process, I don't expect you to read this now, but you can read it later. Something happened. A company contacted them and said, we have a way that you can 3D print polyurethane that you're going to use for those soles. And it's as inexpensive as doing the mold. So you don't have any upfront cost, and you can instantly make kids' shoes, women's shoes, half sizes, left size one size, right side the other size. You can make any shoe you want to fit any foot, and each individual shoe is the same cost as if you had done this mass manufacturing approach. So it de-risked, it took a lot of risk out of the company immediately, and it also gave them a much, much better product. So this is, when we think about 3D printing, we often think about kind of little toys that you might print and we don't really know what else to do with it that's useful. But this is a good example of how it really solves an important industrial problem. Okay, it basically, like I said, it lowers the upfront cost to get in, and it gives you more flexibility as you go on. So what does that mean? This is if you remember one thing from today, I hope you'll remember this. We often think about products as being disruptive, but the way we make products can also be disruptive. Okay, so the shoe itself it's a nice shoe, but the way they're making the shoe is really, really different and has a lot of implications for every industry. Okay, and it's very similar, like I said, to these, where your upfront cost is almost nothing. You can go from idea to prototype and prototype to product with the change in your pocket, if you have a lot of change. So does this scale up to cars? This is a company called Local Motors. I really like their car. I've actually gotten to ride in it, and it's very powerful. It flies over the sand dunes. It's fun. But they started out a few years ago with the idea to make cars in a really radical new way. So they crowdsourced the design of the car. In other words, they found a lot of designers who are not currently employed as car designers, but they really love designing cars and drawing cars and have always wanted to be one. So they had about 25,000 people contribute in contests and in specific, different parts here and there to the overall design of the car. And in 18 months, compared to about 5 years, 60 months for a normal car maker, they had their design, they had it built, and they were selling it. They also did it for $3 million compared to about $1 billion for a typical car maker to come up with the next, Chevy Impala or whatever. So they had a very, very different way of designing and making this car. And the principles behind that are, again, part of these principles of manufacturing that I think are important for just about everybody. One other thing is they don't need to sell 100,000 or 1 million units to pay for the big factory that they're building to, ever break even. They break even, they break even earlier, but their goal is to sell 2,000 of these, 2,000 cars, and then they're done. They can just keep making them if they want, but they have a goal that if you worked at GM or Ford or BMW and you sold 2,000 cars, you would never work in the car industry again. It'd be the worst car ever. So the fact is they can make money at such a small scale is actually a huge advantage because they can obviously make money at big scale too.
And how much this car will cost?
The cost, it depends on options obviously, but it starts at about $65,000 and it goes up to about $100,000. Okay, so one of the other things that's notable is kind of like the shoes, every car is different and unique. You can see this is just some of the examples of the designs that people have come up with. Now, not every single part of it is unique, but the outside is designed pretty much any way you want it. And the reason is not just a way to appeal to customers, but it was a manufacturing decision. One of the hardest parts of making a car is paint. Paint has to be perfect. The process is very toxic, so the paint, obviously is itself a toxic chemical. But then if you want to change from white to black paint or black to white paint, you have to completely clean out the machine, or else you're going to get flecks of white on the next car that comes through. So it's a really costly process. And they said, rather than trying to improve on this, we're just going to make every car wrapped in vinyl. So you design the car, we have a vinyl printer, and we print out the panels, and we just cover it, and it looks great. You can get chrome if you want to. You can get black, all carbon black, whatever you want, any design. And then if you get tired of it, bring it back in, and for a small amount of money, less than it would cost to repaint, we can make you a completely different looking car. So that was just one of many things that they did. They also have some parts that are completely unique that they 3D print instead of molding. So you take a $20 part is now a $2 part. But I think one of the biggest things is that they just drew on the existing resources out there. So they didn't design a new tail light, and they don't manufacture tail lights. They buy surplus tail lights that the service center for Honda does for a Civic. It's just a Civic tail light. The rearview mirror, they didn't design and they don't manufacture rearview mirrors. They buy them from the company that makes rearview mirrors that go into another car. So some of the things they really specialized in, and so some of the things they said, there's a huge existing supply chain and this stuff is really cheap. Why don't we just use that? If I hadn't told you that, you wouldn't have known it, right? So it's still a great looking car and it looks unique. Anyway, it's a new way of thinking about manufacturing. And they apply it to a lot of other things as well. So if you go to their factory, they don't just have a big line assembling cars. They've got some cars going on over here and some motorcycles over there and some drones they're building over here. They've built a factory that can build just about anything. And it's also very small. They call them micro factories. So they're about 5,000 square meters, very, very small. But they can produce quite a lot of, again, a lot of different things. And one of the other things is they also function as a retail location. So if you want to buy something, you actually go into their site. They're small enough that they can fit in city areas. So a lot of countries have certain distribution rules about who can sell what. But if you're making it in country, you can sell it right there. So for people who are really interested in seeing how their products are made, they want local vegetables and local clothes. This is local everything else. They are doing something really crazy later this at the end of the summer in September. They're going to be at a manufacturing conference and 3D print a car on stage and then drive that car off. So it'll be a real good demonstration of whether their process holds. Now, they like I said, they really want to expand this into a lot of other areas. And one of the companies that's, they also just closed a $40 million Series D, and they're collaborating with GE on this project. It's called First Build. So First Build is General Electric's new way of thinking about manufacturing. So I talked to somebody from General Electric, and they said, we're really good at making one thing. We're really good at making 1 million things, but we can't make 10,000 things very well. And so there are all these little markets that if we could satisfy them, we would love to, but we just don't know how to do it today. So First Build is their approach to this small-scale manufacturing. And the first thing that they're looking at is what they call micro kitchens. So all around the world, people are moving into cities, they're moving into apartments often, and they're having smaller families, and they don't need this huge kitchen that we all think of as, a kitchen. They want something that ideally fits in a very small space, but still is, can make good food and feels modern and fresh and doesn't feel like a compromise. So they're developing micro kitchens, all the different appliances that you could imagine would go into a micro kitchen, and they're using exactly the same process that Local Motors developed. In fact, Local Motors is hosting the campaign site for First Build. Indoor grilling is their next challenge. They've also got some other partners like MakerBot, which is one of the leading 3D printer makers, and TechShop, which I'll tell you about in a moment. So TechShop is what's called a hacker space or a builder space. So it's like if you go to the gym because you don't want to have all these weights and machines at home, you go to a hacker space because you want to have a 3D printer or a soldering iron or a laser cutter that you don't have room or money for at home. So you pay a membership fee and then you go and use the stuff and then you go home. TechShop is probably one of the biggest ones, and it's a chain. And Ford collaborated with them, basically gave a bunch of their R&D employees free memberships to TechShop, and within a year they had a 50% increase in the number of patentable inventions. So TechShop is basically trying to take this model of hand building things in these types of skills and prototyping into products and expand into a number of different, dozens of different cities around the world. Ford, as I said, collaborated with them, which is really new for a car maker to open up their process that way. And this is a good transition into this, some of these areas where emerging markets are appropriate. Because in a lot of emerging markets, you don't want to build one great big factory making something and then import everything else. Ideally, you'd have small factories that fit and can produce what people need locally. And that goes for emerged or developed countries as well. So some of the areas that we see opportunities here, with connectivity, we've talked about aging populations and resource scarcity being three big drivers. There are a lot of things that basically come out of that. And again, and for those of you taking pictures, this is great, but you also get the slides and they'll probably be better than your pictures. So, but areas like water conservation is something all around the world is really important. Right now in California, we have what we're calling a 500-year drought. In other words, we haven't had this little rain for 500 years. It's really, really impacting everything. So water management is not just something that developing countries need to think about. A lot of developed countries do as well. We don't need to think about it this week in Moscow so much. There's plenty of water. But things like sustainable mining, robotics, telemedicine, these all do fit into bigger needs. So a few areas here in agriculture. We're looking at, again, not just the biological opportunities, but some of the, I mentioned earlier, Internet of Living Things. There's a lot of ways that living things tell us about their health that we can detect with drones and sensors mounted on drones or in the field. One of the big areas here, so I've got on-farm, Moroni Bioinnovations, Monsanto, Novozymes. They're all collaborating on different aspects of this. But just to talk about the autonomous systems that we've mentioned earlier, the ability to use drones to scan a field means when we think about precision agriculture today, we think about distributing, say, pesticide very precisely in a field. But in the future, we might think of, why do we need to grow just one great big crop in this field? Why couldn't we have 12 or 20 microfields within this field if we can really control them precisely? So there's new ways of thinking about agriculture altogether that these technologies make possible. Again, this is one of these slides you should read and not try and get today. But the what this shows is basically within water. As I said, water management is a big problem, and recycling water is a big part of that. So there are a lot of different companies that are making sensors for municipal water management and other water treatment that look at this is some of the different reasons they look at it, from monitoring, forecasting, control, for organics, nutrients, and solids treatment. So this is a map of the startups that are working in these spaces. And this, as I said, is primarily it's a municipal water opportunity first, but then these migrate into lots of other areas like oil and gas and agriculture, desalination, and mining. So these technologies are not just limited to one industry. And so if you're looking at sensor technologies, you have a good field of startups, but you also have partners and potential exits with GE and Veolia and IBM Smarter Water. Okay. So, and we expect this opportunity to grow because water stress is more and more prevalent. Integrating all these things, that's always the thing that comes after we get a lot of choices, is somebody says, okay, this is the way we get all those choices to work together. So Takadu is a company that's basically looking at integrating all this information from industrial sensors to operations to even global or geographic information systems and other things, and giving that, turning that into more analytical tools about water supply. And think about what I was saying earlier about predicting and adjusting in advance. That's where this is all going. Smart water. So looking at the mental mindset, I think my impression is that Russians give themselves quite a hard time for not speaking up enough and maybe not speaking English enough and things like that. Those are certainly good things to everybody should get better on, but it's really not different from a lot of the other countries that we go and visit, so don't be too hard on yourselves. And you've also got, I think, a very curious and active generation that's in engineering schools right now that I see a lot of and that has a lot of ambition. Sometimes I see them outside of Russia, and I'm going to show you some examples there. This, I think we will skip in the interest of time, but basically, there's a famous scientific experiment where some children were presented with one marshmallow, and the psychologist goes out of the room and he says, if you can wait till I come back, you'll get 2 marshmallows. Okay, so it's a lesson in delaying gratification. So what they found was that the children who were, I think, 4 years old, who could wait until the person came back to get 2 marshmallows, did better at everything for their entire lives. They were better in school, they were better in business, they had fewer divorces, they were just all across the board, more able to deal with what the world throws at them than the people who said, I can't wait, I'm just going to eat the marshmallow. So delaying gratification is a big part of success in a lot of areas, and corporations eat their first marshmallow too sometimes. So some of the areas that we look at, even though we think of there's a lot of detailed analysis, some of it really is just about passion for a specific topic. So DSM made a decision a few years ago to get out of commodity chemicals, or at least exit it carefully and get into higher value chemicals, and especially biochemicals. So they're really focusing on the bio-based economy. These are some of their partnerships. DSM, by the way, if you don't know, is a very large Dutch chemicals company. Energy, similarly, this is an energy company, and if you look at the things that they've decided to focus on, U.S. energy industry is going to be increasingly impacted by long-term societal trends towards sustainability, which is generational and irreversible. So this doesn't mean it's not a fad, it's something that they have to pay attention to. And they see the information technology part of that as really being important. Mondelez is a food company. You can look at what they're doing in innovation and innovation funding. Basically, big companies often have a lot of inertia, as you, I'm sure, know, so they have a hard time coming up with new ideas because people are focused on short-term goals or internal politics. So a lot of companies are using things like crowdfunding, which we've mentioned, conscious capital, and competitions. These are all rising sources of funding that companies are looking to tap into by taking their internal resources and putting them basically more as free entrepreneurs. The numbers here, this is almost as much as venture capital. So these alternative sources are actually getting very close to the total amount of VC money. And again, they have a number of partners in the field. 3D printing, again, we think about it as just little trinkets and small toys, but a lot of people are thinking very big about it, doing architectural things. So these are 3D printing houses, 3D printing large art structures and also architectural features, 3D printing cars, as I mentioned earlier. Local Motors is going to do that. One of my favorite examples is a company that is looking at 3D printing satellites. So satellites, as you know, are very big structures, but they have to fold up into a nice little compact ball to be shot up on a rocket, and then they unfold in space. And launch is a very, very violent process. People have compared it to being in a car accident. So all that shaking and then needing to unfold, you design a very, very rugged structure that is very complex, like origami. And then it gets up into its orbit after an hour or so of this terrible process, and it never moves again for 30 years. There's no forces on it acting whatsoever. So it's just floating in space. So this company had an idea. What if we took that weight and volume, and we instead sent up a 3D printer and just some spools of polymer, strong enough to survive the microgravity in space, so it doesn't have to be very rigid. Any guesses as to how big a structure you could 3D print in space with that much material? Guess? This is also practice in... Right, but you've got, the limitation is the nose cone. Same size and volume as a standard satellite. It's kilometers. So you can print kilometer scale structures in space because you don't have to think about the weight. You just print, very, very thin booms. So if you're going to do a radio dish, you don't have to ruggedize it for launch. If you're going to build solar panels, that are going to capture a lot of sunlight, you don't have to think about how can I fold this up. You can just make it as big as you need to in space. So anyway, so it's a new way to think about 3D printing. Thinking small is another way. So looking at things like printing bone, printing, devices like this. Now we can print conductive materials inside non-conducting ones. We can use a form of printing, which is placing very small components at a specific location. So you can essentially start to print very, very complex devices, things that are not just materials or components, but that are multi-component, multi-material devices with moving parts and actuators and all kinds of other stuff. So again, thinking about this, taking this to its logical extension, we're integrating a lot of different things. I showed you some shoes. We've talked about architecture. We know they're all going to be connected. So if you start to, again, mindset-wise, think about the shoe as part of the stadium. The littlest piece of something is part of the biggest something. The person practicing their soccer kicks in their home with their gaming device is connected to the pro athletes that they want to be most like. So, the amount of information that connects to these things is obviously a lot. Processing that is a huge opportunity in and of itself. But where we see a lot of the opportunities today, they're in the endpoints here. They're the physical endpoints that sense and feel and actuate and change the world that we live in. So another thing that you should think about for your mindset is you might have had in mind yourself, or maybe one of your younger engineers or something like that. These are my daughters and my son here. This is not only your new customers, but this is your development team. So you hate to think about this as a parent, but so in 10 years, when a lot of these technologies will be popular, and she'll be 21, she'll be 24, he'll be 18. They won't say, "Dad, I want to take the keys to the car," or it's so much fun to drive a car that's not autonomous. They'll just assume that that's how cars are. The way we assume, kids today never get lost. They have maps everywhere they go, right? You remember when you had to carry a map anytime you went to a new city, or a little phone book that you wrote in? These are, ridiculous things that they laugh at us for. So this is your customers and your development team, so look younger. So finally, some specific strategies and things that Russian industry and entrepreneurs can do. I'm actually going to not go through this. It's all written and it's too long. So we're looking at the economics of all these things. And the one that I really wanted to just focus on was this. This is the model of the flexible manufacturing I talked about before. So normally demand is this green line, production is the red line, and you never ever get them to match because production has to be as constant as possible. Demand varies by season, by new competition, by price, whatever. If you have a flexible factory, what you can essentially do is have 4 products where you formerly had 1, and you can try and match that demand curve perfectly. At the same time, you can also experiment with new products. So that's what this says. Please read it if you're interested. This is Tech Shop, I mentioned earlier. This is a maker space. This is such an important thing in the US right now in the manufacturing community that last week we had the first maker shop at the White House. So it's definitely a national priority. This is another example, one called Lemnos Labs that's based in San Francisco. I like them a lot because they really focus on hardware, and I think they have a good view of the economics as well. But I also wanted to show you this, Hacks Asia. Does anybody know Hacks Asia? No? So this is actually a Russian guy that started this. And they do a lot of the same things that I was talking about. They invest in entrepreneurs who have an idea. I met probably 8 of them a few weeks ago at an event in San Francisco. So all these Russians who are based in Singapore are coming to San Francisco to test the market for their goods. And I had to ask them, why are you not doing this in Russia? And so you can probably imagine a lot of the reasons that they said, with getting funding and political situation and other things like that. But the point is, this is a really adjacent set of people, a community of people that you can tap into, and you should. So I intend to introduce this guy, Slava, to you guys at RVC and hopefully strengthen those connections. But you don't even have to go to Singapore. This is Neuron Hackspace. This is literally the same train stop. Well, maybe not the same. It's Kitagorod. So just a short walk from there is this Hackspace. And they've got 3 startup companies in this space. Well, they have lots of 3D printers and all that other stuff, lots of members doing their own projects. But they've got 3 companies there. One is this company called Fairwaves. This is one of the founders. His name is Alexander Chimeres. And he's showing a box that is basically it's a GSM base station. And they're designing it for the developing world. But if he's right and it works, then you could have a cellular subscription for about $1 a month. So from $100 or whatever you pay to like $1 a month. So obviously that would be very disruptive in the developed world too. Another one is the Cubic Robotics that I mentioned earlier. This is actually some Russian that I can read. Привет, человек. Меня зовут Cubic. Я робот с характером. So, and I even know what that says. So this is the sort of Siri for your house, where you talk to it, it talks to you, it has moods and blah, blah, blah. So when I was there on Tuesday, they were actually designing the packaging for it. So they're really starting to get ready to ship. So this, like I said, you could literally take a taxi and see these guys. And I think, if nothing else, it's a good way to interact with a whole lot of Russian inventors and idea makers who don't need a lot of funding. They're also very connected with the global makerspace, so you can learn a lot about that from them. So to wrap all this up, there's a lot that's going on in technology where we see new investment opportunities: wearable and ambient electronics, robotic and autonomous systems, distributed manufacturing. In climate change, agriculture and water are good examples of the intersection between information technology and the physical world. And then in this mindset, passion and thinking big, those are all really important. Obviously, you need to back that up with data and analysis, but I think often the first step is the hardest, is not to talk yourself out of a good idea too early. And then finally, these microfactories and hack spaces in Russia. Local Motors, by the way, is hoping to develop or establish 50 microfactories around the world in the next 5 years, and I think Russia would be a great fit for them. So I'm hoping that we can find a way that the Moscow State University of Mechanical Engineering could be a site for a hackerspace a microfactory from Local Motors in Russia. And if you're interested in that, please let me know. So yeah, hopefully I've given you some specific ideas and people that you can reach out to. I'm obviously very interested in helping you with that as well. So thank you very much for your time and attention, and I'd be happy to take any questions. By the way, somebody asked about could this be hacked. So this is actually turned on my music, so my music is playing now. So thank you to whoever did that.
Hi, Mark. Thank
nice
you.
to see you again.
Yeah. Thank you very much for a very interesting and inspiring lecture. And my question will be completely outside of technology part. You were saying a lot about some technology trends, that how people are getting acquainted with technology, what are doing with that. But if we think from psychological standpoint, a lot of mass market, they have no idea what's going on inside Pebble, inside all this, variables, clouds, whatever. Do you think that some additional like courses, I don't know, like tech shop for psychological changing of mind should be in place, like
I think
technological sandbox to do something like hack space and something to change how you interact with technology.
Yeah, I think that's a really good point, and it is definitely a need. Most of the hack spaces are populated by people like maybe everybody here who really like technology, sometimes for its own sake. And there's the classic innovators, early adopters, early majority, that curve that very much holds still. So some people would rather have a Samsung smartwatch because it's from Samsung. So I think that the psychology that we're looking for here is sometimes about branding too, and how do you package something so it's attractive and it looks like a product that's maybe from, say, Apple, but it's from a startup. So I know, like the boxing that they were working on for the cubic robotics, they wanted it to be an unboxing experience. Like when you open an Apple box, there's a certain sort of Christmas morning process you go through, and they're trying to design that same type of opening process for the box for the device. So yeah, but very good point. Yeah.
Да, коллеги, можно, в принципе, задавать вопросы по-русски, потому что есть переводчик для Марка.
Thank you for the lecture first. And you had some analytics in your presentation, but as far as robots are concerned, at least consumer robots, you just mentioned that there is an increase of interest to consumer robots. Well, of course, that's obvious. But do you have any kind of authoritative analytics in this regard? Could you point to any authoritative source and useful source?
Sure, I have a few very small examples. And so this is it's at an early stage. You often don't have good global metrics. But so last week I was in Sweden, and they were saying that because there's really no new features, no must-have new features in tablets or mobile phones anymore, that the interest in them has dropped quite a lot. I think they said 40% from last year, 40% fewer people intend to buy a new device like that next year. Robotics, on the other hand, had gone up 150%. So this probably 40% down from here and 150% up from here. You know, they're a very small number and a very big number, but I think directionally, it's not surprising that they're going that way, and in 3 to 5 years, they'll probably be, you know, a lot closer.
Yeah, thank you. But could you point to any, I don't know, organization maybe which compiles such analytics to look at?
Yeah, no, I don't think I haven't seen them because, again, I think it has been, this is a typical thing in market research where if you're asking a lot of people about something and they say, I have no idea what you're talking about, then you can't get very good data about their intentions there. So the earlier question about bridging the gap from the innovators and the consumers that want new technology because they want all new technology to mainstream consumers, I have no idea, and I don't think anybody has an idea what that will look like. Typically, you know, you see that you can think of innovator's dilemma. There'll be some startup that has this really cool new technology, and from one day to the next, nobody will know about it, and then everybody will know about it. Like we see that with Oculus Rift. Virtual reality was always 10 or 20 years out, and then one day a company says, we really have something that's working here. And then in a few months, that sort of becomes the reference.
Thank you.
Well, thank you for a wonderful presentation. You gave us quick overview of the current technology trends, but you deal with the venture funds, you know, the U.S. venture industry. What's your opinion about the trend in the U.S. venture industry, where it's going? Thank you.
I don't have really a high hopes for the U.S. venture industry in a lot of ways. A lot of the U.S. venture industry, something like 65% goes to either medical biotech or software. And both of those, if you look at their sort of, you know, S-curve thinking, they don't really change as rapidly anymore as they did 5 or 10 years ago. So the need for venture investment is less because it's more predictable, and the willingness to invest what it takes to, for example, make a new drug is also less because the payoff is less. So for a long time, the long-term trend has been less and less venture investment, fewer and fewer funds, and just, you know, most of the long-term metrics are going down. We're having a good year this year compared to last year, but that's after lots of years of decline. So I think that for a lot of these types of technologies, that's why crowdfunding, for example, has been very popular. That's why corporate VC has also been very popular. It just has different strings attached to the money. And going back to what I said about the prototype is the product, the real big thing there for funding is that you don't need as much up front. I mean, venture capitalists are already saying, well, if you haven't already sold it, why are you know, I'm not going to put money into that. So I have some other slides about, it's called the hardware startup fairy tale, where the idea is you're a .com company and you get investment and then you get big, but the reality is very different. You're either if you don't make at least $1 million or more on Kickstarter, you're not going to get any venture funding. There's almost no company that's done that. Excuse me. Almost no company that has gotten venture funding without first breaking like $1 million in Kickstarter.
Okay, Mark. Thank you very much. You have. Okay, last question.
Okay.
Thank you very much for a wonderful presentation. Maybe a strange question. How do you identify emerging technologies? I mean, do you think it's possible to name some formal indicators or heuristics on the fact that emerging technology has some disruptive potential, for instance, at the stage of weak signals or something like that?
Yeah, so the question was, how do you identify emerging technologies? Are there any sort of heuristics for how to distinguish sustaining versus disruptive, correct? So identifying them, well, finding them in the first place is obviously a big part of it. And so the easiest way I can think about explaining it is you go to where the innovators are. And that sounds very obvious maybe, but I think what a lot of people do is they go to where they think there might be an innovation, or they sort of wait to see if one happens. But you know, university partnership would be a typical example. But one of the reasons I like going to these hacker spaces and Maker Faire and things like that the most is because you don't go there to see what is there only. You go there to see what people are talking about that they've seen. So they're essentially your pre-scouting network is the things that they're working on, or the ideas that they've had, or the conversations that you pick up there. So I think the first thing is going to where the innovators are. As far as identifying disruptive versus incremental, everything looks incremental initially, or people are just talking a lot. So what you really have to do is, one, do the math. So you have to really think about what's the size of this market. Will this new technology change that market in some fundamental way? Like, I don't expect anybody to buy a second vehicle because it's autonomous. You know, the car market will stay the same size, but autonomous vehicles will take more and more of that. So that sounds very incremental. Where it's disruptive is you have to really think about it creatively and differently, and look for metaphors and analogies. And that's why I think the Google analogy and Android to handsets is an effective analogy in automotive, is because the mechanisms by which Nokia and Motorola were disrupted are really similar to the mechanisms by which GM and Volkswagen could be disrupted, and that the existence of a third tier that is getting very close in quality but needs a boost in another area of technology. Again, the HTC Samsung to Cherry and Tata is also just a good analogy. So that doesn't mean it will happen, but it means that it's plausible. And there's no real good way to do math on that. You can try, but what you can say is, strategically this is important, and we need to watch it, so we're able to get that data, so that when it's there, when we have facts, that we'll be able to have a little bit of warning. Is that good? Okay. Oh, all right. So yeah. Oh, sorry. Okay. Yeah. I'm sorry. First time I've ever been to the Bolshoi Theater tonight, so I have to go.
Thank you very much, but I wanted to ask, do you prefer to work with open source code, or you like to hide your code and you don't like to share your software? And the second question, do you work with Unix-like system, or you have your own systems, you develop your own systems?
Okay, sure. So the question was, do I like open source versus proprietary software, and do I work with any Linux types of systems? So first of all, I'm not a developer myself, and our company doesn't develop software, so all these things that you see, if anybody wants to steal it, I would be so proud of ever having done something that was that good. So I'm absolutely open source. What's more important, though, is whether companies should be open source or proprietary. And, oh, by the way, on Linux, so we have a Raspberry Pi at home. My daughter has a Raspberry Pi that's a Linux-based system. So the things that you want to be open source are the things that you don't intend to dominate. So in other words, if you have to really, as a business priority, make your money on, say, operating system software like Microsoft, you absolutely don't want that to be open source. But just about everything else that is going to help you sell more operating systems, yeah, that's great if that's open source. So like with Pebble, they don't want to make and sell applications. Apple doesn't want to make and sell iPhone apps. They want to make the ability to develop and change and grow basically that ecosystem as easy as possible. So open source hardware, which this is, by the way, that's what this little gear means. That's the open source hardware sign. That's what's making this all possible. So people are basically saying, I'm going to sell some chips, but my chips are going to be better and I'm going to make them faster. But anybody that wants to use the same basic design can do that, and they'll improve on it. But I'll make those faster too. And other people, because there's such a group of developers able to use these systems because they're open source, then you actually sell more of them than if you tried to keep it all locked up. Okay. Again, thank you very, very much for your time, and I hope to connect with you all again in the future.
Dear colleagues, we of course have a lot to discuss, but we have to let Mark go. So Mark, thank you very much for a very interesting presentation.